At this time of the semester, the bone test is upon you. I'm starting bones. It happens in the upper level group as well. You know, they're about a week and a half in front of you now, and they'll get further ahead of you as time goes on. But the reason I say it's a little unfortunate is because you will have the experience that every other group has in anatomy and physiology, which is I'll get to the end of the skeleton and you'll go, that would have been a really good thing for me to go through before my lab test. So it's not being done at the same time. I'm always a little bit behind here. So the good news is you'll have context for the lecture. As I'm talking about the bones and the processes and the holes and things, you'll be going, yeah, I've seen that in the lab. It's just always good to go through it a couple times, hear somebody talk about it. So by the time we get to the end of it, well, then you'll know the skeleton really well. All right, my approach is a little bit different in teaching skeletons. So I'm going to do some introductory things today about bones and shapes and sizes and different terminology things for bones. And we're going to start on the skull. So we'll get that done today. But as I go through the skeleton, we will not have enough time as I'm going through it, obviously, to teach you all the bones and all the muscles. But this is the bone and muscle test. Test 2 is bones and muscles. So what I've done, and you'll see it in the presentation, is I have inserted places where I'm teaching some muscle attachments. But you will also notice on the portal that there is a list, a short list. There's over 600 muscles, and I've narrowed that down to just the major groupings that you can put your hands on for learning muscle attachments. And I'm going to ask you to have the attachments of those memorized. I'm not going to teach all of them to you. I'm not going to stand up here and teach each individual muscle and its attachment. But I will expect you to know that, and this will be repeated. I'll bring that up again. Also, you'll notice in this presentation, and in the one that follows it on the portal, that there's a lot of information about joints. So really, this test is not just bones and muscles. It also includes joints. So as I'm going through the skeleton, I will say things about joints that will come up as part of my discussion. Just in general, talking about the bones and how they attach and how you put it together, the joint stuff will come up. But I've got a second presentation with joint information in it that forces me to repeat that. So you're going to hear some of the joint stuff more than once for this exam. So you're going to notice there's some repeated slides. The first presentation is a comprehensive bone joint muscle attachment presentation. The second presentation online you will see is it starts with definitions of joints. So after I've been mentioning these to you all along the way, I'll go back again and I'll say, here's how we categorize them. Because most of the stuff I'm going to say about joints is going to be about synovial joints. When we think about joints, we think about things that move us. But as it turns out, they're fibrous and cartilaginous joints too. And so most of those are at least almost unmovable. So they'll come up, but it forces me, like I'm saying, it forces me to go back through it again with you before your next exam. Okay, so that's the overview about where we're going. So let me say a few general things, general observations about bones with you. This is a femur shown here, and you can see that every anatomy and physiology textbook goes through and categorizes bones in different groupings, round and irregular and flat and short. I have no interest whatsoever in your memorizing which bones are short or flat, etc. You have plenty to learn about the bones, about their processes, about their foramen, about their attachments. To be memorizing categories like this seems like nonsense to me. So I show it at the beginning. Your book has it at the beginning. If you look online, they all start with this, different groupings of bones. Do not memorize them like that. Okay. The second thing, general observation here, as we're doing general observations about bones, is the structure of a bone. Now the good news is if you have learned your histology, some of this is already in your mind. For example, if I point out to you that this space is occupied by red marrow and that yellow marrow is here, that should not be a surprise to anybody in the room. Because when I taught you reticular connective tissue, I said this is bone marrow. And so if you look in the epiphyses, in the spongy bone that we find on the ends of long bones, you find reticular connective tissue, red bone marrow. That's what that is. So you've learned this already. And when I showed you the adipose section, I mentioned this to you as well on more than one occasion. The diaphysis of a long bone, the shaft of this long bone, has a cavity in it, a medullary cavity that contains yellow marrow, adipose tissue. Okay, so there's some things here that you recognize. Now, this label, the epiphyseal disc, the articular cartilage, spongy and compact bone, the periosteum, these are words I haven't used with you. So I'm going to teach you these. So let's start over here. The ends of the bones are called the epiphyses. You know they contain reticular red marrow. They contain bone marrow. All right? Let's say one more word about that. Okay? As we talked about blood in the connective tissue, I mentioned to you that blood, this blood is all produced from stem cells that we call hematopoietic cells. So we did fibroblast for connective tissue proper, chondroblast for cartilage, osteoblast for bone, and hemocytoblast for blood. And so I describe blood as a hematopoietic tissue. I keep using this term. Okay, the reason I bring it up here is because you already know that red bone marrow is here. I have given you this list in short before, and I'm going to give it to you again. These are important locations in the skeleton where you will find red bone marrow. This has clinical implication. All right? How are you going to get a sample of red bone marrow to diagnose leukemia? You need to know where it is. Okay? So here are the places in the skeleton where you will find spongy bone containing red bone marrow, blood cell producing tissue. Start at the top. Your skull bones. We're starting with the skull today. That's going to be our first major part of the skeleton to learn. The skull is a sandwich. It is a sandwich of compact bone around spongy. So normally, in the anatomy of a bone, you have compact on the outside, spongy toward the middle. The ends are mostly spongy. We're going to say this again, okay? Spongy bone is this cavity-laden kind of irregular arrangement of bony stuff. Okay, so you find this in the skull. Your skull is a dense, compact outside, a dense, compact inside. So it's very, very strong. But the middle of it, the sandwich, the meat in the middle, is spongy bone, and it contains red bone marrow. There's a lot of blood cell formation happening in your skull bones. So the spongy bone of the skull is an important hematopoietic, spongy bone, red marrow containing tissue. Now, whenever you want a sample of red bone marrow, this is not a place to go, the skull. So they do not normally stick large gauge needles through the compact bone of people's heads to get samples of red bone marrow. All right, so working my way down. The flat portions of the scapula, the shoulder, the flat portions of the scapula, the shoulder, also contain hematopoietic tissue. On the front side, the flat bone, the sternum, also has spongy bone containing red bone marrow. That, as it turns out, is a fairly common place to get samples. Sternal punctures to get samples of red bone marrow. It doesn't seem like a particularly safe place for me because it's so close to so many critical and vital organs. But evidently, that's not a big deal. Okay? So top, back, front, back to the back again. The vertebral bones, all the way down your vertebral column. The bodies of those vertebral bones are primarily spongy bone, and they contain hematopoietic red bone marrow. Blood cell producing tissue is in the bodies of your vertebral bones, all the way down. That's also not a place to go. Be sticking needles around in there. There's too many critical things there to damage. And the last one is the hip. The coxibone, specifically the ilium of the coxibone, is a flattened, flared bone that contains a lot of spongy bone, which contains red bone marrow. This is a very common place to get samples of red bone marrow, in the hip or the ilium. All right, so the first thing then is the space occupied by the red marrow, the hematopoietic tissue. It's in the ends of the long bones, but you know now a lot of other places in the body where you find this hematopoietic tissue. All right? Now this labels the epiphyseal disc as the first thing. All right, so just a little note here, and we're going to come back to it. The epiphyseal disc is the remnant of the growth plate. So I'm going to teach you today endochondral ossification. And I'm going to bring this up again. When the long bone has finished growing, there's a disc where the bone and the cartilage have met and the growth is no longer occurring. That's the epiphyseal disc. Epiphyseal fractures, some of you maybe have heard of this. Epiphyseal fractures in long bones can be quite dangerous, especially in the young. So when people are growing and there's cartilage here, right here at this location, even in the adult bone, there's a weakness there. But if you damage that place in an individual who's growing, depending on exactly where the injury is, you can create a situation where the bone does not grow as much as its counterpart. So teenagers and children's epiphyseal fractures can be quite dangerous. It's an important spot, the disc. The articular cartilage I'm also going to bring up again today. This is something that you've heard before. I told you when we talked about hyaline cartilage in the last test section that you find it all over the body. One of the places is in long bones. Long bones, as it turns out, are built from hyaline cartilage models. So you look at a skeleton of a 6-week-old embryo, the entire skeleton is hyaline cartilage. So you've got to develop that hyaline cartilage into an adult bone during development in utero. And some of these bones are not finished yet when we're born. The xiphoid process sometimes doesn't finish its ossification until you're like 25 years old. And all the carpals and all the tarsals in your wrists and your ankles, they're mostly hyaline cartilage for the first couple of years of life. It takes a while for all that bony stuff to finish. So when it's done, we end up with hyaline cartilage on the edges of the bones. So anywhere there's a joint where two bones are meeting each other, a long bone is meeting another long bone, or a long bone is meeting a pectoral or pelvic girdle, you will expect that the ends of those bones have soft tissue on them, cartilage on them. And a lot of times our bodies puts more cartilage in there, like in your knees and your hips and your shoulders. There's fibrocartilage there also to help cushion those joints. So articular is hyaline. You're going to see it again in just a second. All right. Now, this labels compact and spongy bone as two different kinds of bones. So let's locate them. We looked at a picture of compact bone in your last test section. There's nothing really fancy to say about spongy bone. It looks different, and you can see that in this picture. I'm not sure what the best words are here. There are anatomy words given to spongy bone. Sometimes it's called trabecular bone. The trabeculae means a system of caverns or cavities. Sometimes it's called the diploe, D-I-P-L-O-E, the diploe of the spongy bone. But you can use your own verbiage here to describe this. Spongy bone doesn't look like compact bone. It's not compact. It's a series of caverns, and you know what's there. There's reticular connective tissue there. Now notice that even in the epiphysis of the bone, there is compact bone on the edge. So the surrounding portions of the ends of the long bones are compact. They're very strong. The section that we looked at there it looked like a bunch of pine trees. Remember the concentric rings of the compact bone? So you find that stuff here in the ends of the bones too, but the epiphysis is mostly spongy. Now you can see that the spongy bone continues down into the medullary cavity. And so the diaphysis, the shaft of the bone, does contain some spongy bone. But most of the mass of the diaphysis is compact bone. So where is the strength in a long bone? In the shaft. The real strength of the bone is in the shaft. And it's a very interesting phenomenon about the occurrence of this compact bone. It's actually a law that orthopedic surgeons know very well called Wolff's Law. Wolff's Law suggests that you're going to find more compact bone in places where the bone is under greater stress. So look at the ribs when you go into the lab. Where are they the thickest?